Welcome to the Maritime Engineering Category Training and the last few modules required to make you eligible for promotion to able seaman. In Module 7 we'll discuss density, displacement, scientific method and buoyancy. And we'll also investigate Archimedes' principle and what that has to do with why ships float.
Although you're going to cover this in the module, we want to introduce you to these concepts now so you can get a basic understanding about it.
So let's start with density. Density is a measurement of an object's mass or its physical volume. So these have the same physical volume but different densities. One's steel, one's timber. So the weight is different even though the amount of space that they take up is the same. These are 1 cubic centimetre squares of material. And if every material came in 1 cubic centimetre squares, it would be very easy to measure density. However, that's not the case. For example, this piece of steel is quite small, but it's also quite heavy. This piece of polystyrene is significantly larger, but it weighs a fraction of what the steel does. So what you can determine from this is the density of the steel is much higher than the density of polystyrene.
So why does this matter? We know that 1 litre of fresh water weighs 1 kg, or 1 cubic centimetre weighs 1 gram. So if we put a more dense item, such as steel, in the water, it will sink. However, if an item weighs less than the same volume of water, or is less dense than the water, such as wood, it will float. Knowing this big heavy steel ship Rupeg should sink, shouldn't it? Well, that's what displacement's all about. In this context, displacement refers to the amount of fluid an object pushes aside. For example, when you hop into the bath, the water level rises. Essentially, your body takes up the space within the water, causing the water level to rise, and the volume of that rise is the displaced volume. This displaced volume is equal to the volume of your body. But what if the object has less density than water? That is, its mass versus the volume it takes up, its density, is less than the density of water. Okay, let's find an object that can float on the surface of this very full container of water. Now, if we float our boat on the surface and then start adding weight, we can see the water flowing over the side of the container. This is because we have displaced the water by increasing the mass of the volume, adding weight. So if we weigh this water, we will notice that it matches the mass that we have added.
When we pour that water into our container, it should weigh the same as our boat. A couple of grams difference.
Also, if we keep adding weight and eventually reach a density that exceeded water's density, that is 1 gram per cubic centimetre, then the object will sink.
Rupeg is also affected by this principle. As we add weight in the form of people, stores, water or food, our overall mass increases. In turn, that makes us sit lower in the water, increasing the amount of water that we displace. But the biggest issue for us is that a higher mass increases our draft, which is the overall amount of boat under the water. And this reduces our access to shallow water. So as you can see, we're all affected by Archimedes' principles. If you still don't know what that is, that's okay. You're going to cover that in the online training.
Good luck with the material.
We'll see you further into the training.